All right, so October, November 2017, variant 3 for AS economics MCQs. I'll be splitting this paper into 3 videos. I'll be solving on spot. I'll check myself after every 10 MCQs. So basically at the end of the particular video. Okay, so question 1, what distinguishes the very long run from the long run? Now, what you should know is that when you go from the short run to the long run, the distinguishing factor there is how in the short run, you for a firm at the very least they have at least one factor input or factor of production that is fixed. In the long run, all factors are variable. When you go from the so that's the idea here, like one factor of production, at least one factor of production. Um, whoops, yeah. So at least one factor of production is fixed. In the long run, all factors of production are variable. You learn more about this in A2. I'm surprised to see this in AS, but anyhow, you should have basic knowledge just to be able to answer these few MCQs. But when you go to the very long run, it really changes. So in the very long run, the idea here is that the level of technology that's available to you. Now, in the short and the long run, you assume that level of technology is fixed. So you can produce in a particular pattern, you have a particular set of technology that's available to you. In the very long run, even that level of technology can change. That's the idea. So level of technology, that's also in a way variable that can change. So you'll be looking at something along these lines. So you can change resource allocation in whatever run, change the state of technology. That is, what can happen in the very long run, but cannot happen in the long run. Government intervention is independent of whichever time period you're in. And variable factors of production, well, that is something that exists in the long run, but it exists in the very long run as well. It doesn't exist in the short run. So you can have B. What is least likely to happen if a firm decides to increase automation? So basically, its capital, so its capital stock goes up, basically more machinery and stuff of that sort, and division of labor in its production processes. So this should increase productivity because that's basically what specialization and division of labor does. As you split up the production processes into smaller parts and put the right labor in the in those particular in processes, it helps them get specialized. The right man is there for the right job, and obviously if you increase automation, that also helps productivity. So if it's increasing productivity, it wouldn't increase cost per unit. It would in fact decrease cost per unit. In fact, wait, hold on a second. So they're looking for what is least likely. So increase in productivity is something that is likely, which is why I can cost it out. If you increase productivity, increase in firms' profits, because total revenue is more or less the same, but cost has gone down. So that is also likely, which is why I can cross it out. An increase in the number of workers employed, and an increase in cost per unit. So the idea here, now both of these things aren't very likely to happen. One, because, well, if you increase automation and you increase division of labor, usually what happens is cost per unit falls. You become more productive. At the same time, though, increase in the number of workers employed, normally when you increase automation, you normally get rid of workers. You substitute labor in favor of capital. However, what is the less likely out of the two, I would say that would be A, because, well, if you have automation and you have division of labor, like almost for sure you've become more what do you say, more efficient, more productive. You're fixed. So the idea here is every additional unit that you're producing, that you'll produce in a much less cost. So your cost per unit cannot increase. It should definitely go down. So that's why this is going to be least likely. The reason why you can exclude D is because Well, number of workers usually go down when you automate, but it doesn't necessarily have to be so. If you have division of labor, you might then want to employ more workers. Now that you've divided the production process, it could be possible. At the same time, you might want workers to operate that machinery, that additional machinery that you've brought in. So it could happen. It's not likely, but it's not definitely not the least likely out of the four options. So you have PPCs for four countries with statement about the opportunity cost of good R in terms of good S is not correct. So let's see. It is greater at all points on R S so RS4, so this one, then on RS3, the opportunity cost. So the opportunity cost of good R in terms of good S is basically if you're producing good R, you have to forego some consumption of good X S, and that basically would be your opportunity cost. Now, in this particular case, your opportunity cost with regards to PPCs depends on the gradient of your line, basically. When you have a straight line, we say it has constant opportunity cost. And if there are two parallel lines, you can say that the opportunity cost for producing R, in terms of S is that's going to be the same for both of these lines. So is not correct. So it's greater. That is wrong. So you can take this because this is definitely not correct. And let me just show you this in a little more detail. So think of it like this. Let's say you want to produce this, you want to produce R. Now, to produce R, what do you have to do for R3, S3? You have to reduce this much of S, like if you go from 0 to R. So you have to reduce this much of S. This is your opportunity cost. If you look at what happens if you want to produce the same level of R, but you're on R4, S4, then you have to reduce this much of S. So if you look at it, well, maybe I've drawn a little, I might not have drawn the best, but the idea is both of these two horizontal distances are supposed to be the same. So you can't say it's greater at all points. It might be the same, in fact, in all points. So it is greater in country 3 than in country 2. Well, we know, so if you look at this, it is greater in country 3 than in country 2. So country 3 is this, and country 2 is what happens here. And that's, I mean, again, you can just draw a line. Think of it like you want to produce R, so you're going up from 0. So for country 3 to get this much, you have to let go of this much of S. So this is going to be your opportunity cost. But for country 2 to get this much of R, well, it will be a very small amount of S that you're letting go. So obviously, it's the opportunity cost is greater in country 3, since you're letting go, you're foregoing more of S. It is lower in country 2 than in country 1. And that, again, I'm not going to do that all over again, but the idea is country 1 would have the same opportunity cost as all of these, because it's about the gradient. So if country 3 has a greater opportunity cost than country 2, that's the same thing as saying country 2 has a smaller opportunity cost than country 3. And if country 1 has the same opportunity cost as country 3, that's the same thing as saying, well, kind of like substitute 1 with 3 here, and you'll see that country 1's opportunity cost is greater than that of country 2. So obviously it'll be lower in country 2. So just by knowing this, you can also cross out this. Or if that didn't make sense, you just go ahead and draw those lines all over again. It is the same at each point on R3, S3. Yes, obviously, because all of these straight lines represent constant opportunity costs. So at all points, along a particular PPC, it's going to be constant. It's going to be the same. Many governments are concerned that high sugar content in fizzy drinks might lead to health problems such as obesity. The governments are also concerned about the lack of public awareness of such dangers. What can be concluded from this? Consumers of fizzy drinks have information failures, possibly because they consider the lack of public awareness about the dangers of consuming fizzy drinks. So that's an information failure. They definitely don't under consume it. In fact, they're perhaps over consuming it. Fizzy drinks cannot be said to be merit goods. They would have to have some sort of external benefit for that, which is definitely not the case here. Fizzy drinks are not public goods, which would be non-excludable. Non-excludability means that you cannot exclude non-payers from consuming it, and hence you cannot charge a price. Clearly, you can charge a price for fizzy drinks if you don't pay for the Coca-Cola. I mean, the dude's not going to give you the Coke. So like, how is it not? How is it non-excludable? It's clearly excludable. There is a fall in the world price of tea traded on wholesale international markets. Okay, so the price of tea fell. How will this most likely affect the supply curve of a major tea seller? Look at the supply curve of a major tea seller. Well, that was kind of drawn out of proportion. This is a supply curve. Let's say this is the market for tea. And the idea here is so there was a fall in the world price of tea traded on wholesale international markets. And yeah, but you're looking at a major tea retailer. So even if you think of it like that, a major tea retailer would do what? It would be buying the world price. It would be buying tea from wholesale international markets. In fact, so if I can just cross out, the operatives here, how this is the fall in wholesale international markets, and this is a retailer. The retailer isn't going and going into Sri Lanka and getting tea, growing tea himself. A retailer will simply buy tea and sell it from the wholesale. So it's going from the wholesale to the retailer. So for the retailer, if there's a fall in the price of tea on the wholesale market, in a way, there's a fall in a raw material for it, or a fall in a factor input for it. So the idea here, raw material might be a better way to put it. But the idea here is then the cost of production decreases because it was buying tea as its raw material or as something that was taking in, and now the price of that has fallen. When cost of production falls, we know supply increases. That's a factor of supply. Supply increases to the right. In fact, I didn't need to make this diagram. I don't know why I did that. It was estimated that in 2015 that milk had an income elasticity of demand of minus 0.6. So one thing you should know, if there's a negative sign, and this is, you're talking about income elasticity of demand, that means there is an inverse relationship between income and the quantity demanded, which obviously is the same. For our intents and purposes, we can say it's almost the same thing as demand with regards to relationships. I mean, let me just show you that if income increases, demand for the product decreases, so quantity demanded also decreases. So you can just group this into one thing. But the idea here is between these two, there's an inverse or a negative relationship. And what does this happen? Which good? It happens for inferior goods. So knowing that, we can look at the options, and like you can just circle D right away because, well, it's kind of obvious it's an inferior good. It doesn't have, well, substitutes. So these two are looking at factors of PED, which you can cross out. Household expenditure on milk will decrease if the price of milk increases. Again, they're treating it as they're looking at price and quantity. I mean, and that has nothing to do with the figure that you're given, that is of income elasticity of demand. So you can just cross those out. Which statement about the price elasticities of the curves are correct? So you have supply curves. Curve 1 has constant infinite elasticity. That is wrong. It is perfectly inelastic, which has elasticity of 0. Infinite would be if it was horizontal. Curve 2 has elasticity greater than curve 4. over its whole length. So if you look at curve 2 and you look at curve 4 is more like it's like in a way flatter, and the flatter you get, the more elastic you get, and hence you have, a curve 4 would in fact have a greater elasticity, a higher value of PES, not curve 2. Curve 3 has increasing elasticity as price rises. So now we'll have to look a bit for this one. So we had learned for demand uh, that over this thing, it was for small quantities, it was elastic, then it was equals to unity, then it used to be inelastic. The same pattern follows for supply. For small quantities, it is elastic, and then it is, equals to 1, and then for the rest of it, it is, at some point it becomes inelastic for larger quantities, and there's a mathematical relationship behind it. I don't want to go into the nitty-gritties of it right now. So if it so the idea here is, as price rises, quantity also rises. So if you're basically moving like this from the curve, and it goes from elastic to 1 to inelastic, so that's like saying greater than 1, 1 less than 1. So clearly elasticity is decreasing, not increasing. Curve 4 has decreasing elasticity as price rises. Yeah, basically. So that's exactly what we discussed over here. The data shows both short-term and long-term changes in the quantities of a product that are supplied to a market in response to an increase in its price from 20 to 25 per unit. So the quantity supplied at price 20 per unit is 400. Quantity supplied when after short-term adjustments, when price rises to 25 per unit, is 440, and after some long-term adjustments, it's 560. What are the short-term and long-term price elasticities of supply for the product? So what you should know, price elasticity of supply is percentage, sorry, so it is percentage change in quantity supply to percentage change in price. And the way you can find out percentage change is very simple. You can go, so percentage change for any particular quantity is the new value minus the old value gives you change. You subdivide that by the old value and you multiply all of this, the entire bracket, by 100. So that's how you calculate percentage change. So if you look at it for the so let's first calculate, in fact, the change in price. So that was what? That was 5. That would be 5 upon 20 into 100, like so around 25%, I believe. I don't have my calculator with me, so just quick trying to do some mental math. And if you look at the short-term change in quantity, that is like, I believe, 10% increase. So clearly this is going to be something like 10 upon 25, which should be, if you do it into 4, that's 100. Yeah, so that should be equal to 0.4. Again, it's just ideal if you just pop that into your calculator, makes things easier rather than trying to do them mentally. We look at it for the long run. So for the long run, that would be 560 minus 400 upon 400 into 100, and the change in price is still the same. That's 25. In fact, let me go grab my calculator. I think this is going to be a little tricky. All right, so now, like a sane person, I can use my calculator to calculate. So I'm getting a 40% change here in quantity, which for the long run, which means it's 40 upon 25, which obviously gives you some value above 1. So it's 1.6, and that also coincides with our answer. So we're fine with that. Basically just calculate percentage changes respectively and just pop that into the formula that I quoted. In the diagram, D is the demand curve for an agricultural commodity, and S1 is the initial supply curve. A good harvest causes the supply curve to shift to S2, so supply increases. By how much will the demand curve have to shift to leave farm incomes unchanged? So farm incomes, basically the farmer's total revenue unchanged, and the total revenue is price into quantity. Now, what was your initial equilibrium? It was this. So your price was 5, your quantity was 2. Well, 2,000, but like, yeah, forget that. Just let's say 2. It's easier that way. So your total revenue, your old total revenue was like 10. And now you have to see at what point on the new supply curve will your total revenue be 10 as well. And it's kind of looking out, it's kind of like staring out at you. So this point, right? Because here price is 2, quantity is 5. So here your total revenue will also be 10. So you want to see by how much will demand have to shift such that it reaches, it goes something like this, that it intersects the new supply curve at this particular point, at point E, let's say. And they've given you shifts with regards to quantities. So if you look at it, an easy way to look at it would be to just look at this point here. So at price 2, it was 4,000. Now you want it to be equals to 5,000. So you wanted to shift like 1,000 for every price level. So this all of this is going to be 1,000. So 1,000 tons at all prices. A market is in an unstable disequilibrium when it does not return to its equilibrium point from a disequilibrium position. The diagram shows a market with 2 equilibrium positions. Okay, nice. Which price is the market in an unstable disequilibrium? And they had said before that it is in an unstable disequilibrium when it does not return to its equilibrium point from a disequilibrium position. Okay, so we just have to look at all of these points. So if you look at this would mean that quantity demanded is this much, and quantity supplied is this much. So quantity supplied for point A exceeds quantity demanded. You have, in a manner of speaking, a surplus. When you decrease price, well, I'll just write this down. You should know it already. So when you decrease price, quantity demanded increases and quantity supplied decreases, because quantity supplied follows a direct relationship. Quantity demanded follows an inverse relationship. That's why your supply curve is upward sloping, demand curve is downward sloping. When price increases, quantity demanded falls, quantity supplied increases. So that will be useful here. Anyhow, so when price decreases, your quantity supplied decreases, your quantity demanded increases. Look at it like this: quantity supplied decreases, quantity demanded increases, bringing you to equilibrium. So you're fine with A. So you can just cross that out because that's not an unstable disequilibrium point. If you look at D, because I think we can cross that out as well, quantity demanded is this, quantity supplied is this. Well, in fact, we might not be able to cross that out. So clearly quantity supplied is greater than quantity demanded. So if that is the case, and you want to go to your nearest equilibrium point, so you'll raise prices to go to your equilibrium point. But what would happen is increase in prices, look at this, increase in prices reduces quantity demanded, so it goes somewhere like here. It goes more of this place. And an increase in prices increases quantity supplied, so that goes to the right. So that goes more towards this. So it goes more like this. So what happens is quantity demanded goes to the left, quantity supplied goes to the right, and you never reach your equilibrium point, which is where both quantity demanded and quantity supplied are equals to each other. So in fact, your answer is D. If you want to look at B and C as well, you can. This is quantity supplied, this is quantity demanded. You increase price to reach your nearest equilibrium point. Increase price would increase quantity supplied, would decrease quantity demanded, they would coincide. If you quickly want to take a look at point C here, this is quantity supplied, this is quantity demanded. You try to reach this point because it's the closest, so you decrease price, which decreases quantity supplied. um no, that's interesting as well. If you decrease price, that decreases quantity supplied, but it increases quantity demanded. So I don't think that works. But if you try to go the other way, if you, let's say, if you look at this, quantity supplied, quantity demanded, what if you try to increase price to reach this equilibrium point? I believe then it works, because um, if you think about it, what the overall change is happening is quantity demanded is still decreasing. Overall change, it might not look like it for a bit, but eventually comes back, and quantity supplied is increasing, so that the overall change is still consistent with what we see here, that an increase in price would move quantity demanded to the left, which is decrease it, and quantity supplied goes to the right, so that increases, and they coincide at this equilibrium. So in fact, C could be an option in which a lot of people will get confused in. But in D, no matter whether you increase or decrease price, it's not reaching any equilibrium point anytime soon at all. So you can, it's definitely going to be D then. C, it can't reach this equilibrium point, but at least it can reach this one, right? So you can cross that out. So I'll quickly just check my answers. All right, we're all good for these 10 MCQs. Answers are marked correctly. And we'll continue this paper in the next video. We'll look at the next 10 MCQs there.